Okay, well, earlier we were talking about factoring the left-hand side of this temporary quadratic expression in standard form right here, and we factor it out to be, we factor it out to be 2w plus 3 multiplying w minus 4 equals 0. And using the zero product properties, we set each of these binomial equal to 0, as you can see underneath right here. Separately, in each case, we solve for w by using algebra manipulation. So we got w equal negative 3 over 2 and w equals to 4. Now we are not done yet. Well, at least we're not done with the first half of this problem because we're not solving for w. You have to remember that we are using w as a replacement for the actual variables or for the originally assigned variable x, okay? So we have to convert the w back into the variables x. But if you take a look on top right here, we let w to the first be equal to x to the 1/2 equal to square root of x. All you have to do, replace these two w back with square root of x. So that means in this case, I'm going to have square root of x equal to negative 3 over 2 and square root of x equal to 4. Now we want to solve for x. We don't want to solve for square root of x. That means we have to get rid of a square root of x right here. And of course, easily cancel the square root of x by taking the exponential power of 2 on both sides. They automatically cancel out. So I'm left with x equal negative 3 over 2 raised to the second is the same as negative 3 over 2 multiplying itself twice. And of course, back in pre-algebra and even in middle school that you have learned, or even elementary school, when you multiply any two fractions, you multiply respectively the numerator by numerator and denominator by denominator. So negative 3 multiplying negative 3 is positive 9. 2 multiplying 2 equal to positive 4. So you got x equal 9 over 4. Same thing on the right hand side. You have x equal 4 to the second, so that's 4 times 4, which is equal to 16. Okay. Now, the first half of the problem is done. The second half is we have to check for extraneous solution. Now, what is extraneous solution? Well, extraneous solution is an x variable such that when you plug that x value back into the original equation, the left-hand side will be different than the right-hand side. Or you can say the left-hand side is not equal to the right-hand side, okay? So which one of these two is the extraneous solution? Should there be any? Well, we have to check for that. And of course, just plug each of them in individually. So let's see. I'm going to do x equals 16 first, okay? So let's see if x equals 16, then let's see. Is it true that square root of 5 times 16 plus 1 minus square root of 16 equal, with a question mark, don't forget, to 5? So remember that every time when you check for extraneous solution, always have the question mark, either on top of your equal sign or on the right-hand side, okay? Because you want to make sure to your teacher that you're checking for extraneous solution. You're not saying that the left-hand side really is equal to the right-hand side, at least not yet, okay? So let's see, mental math. 5 times 16, that's 80. 80 plus 1, that's 81. Bring down a minus 16 and bring down everything else. Of course, mental math again. We know that square root of 81 is 9. We know square root of 6 is 4. Subtract that. Guess what? 9 minus 4 is equal to 5. So, because both hand sides of the equal side are the same, that means x minus 6 is the solution, not the extraneous solution. Okay, but that doesn't mean that the other x value, 9 over 4, is also the solution. That means we have to check it in to see if it really is the solution or the extraneous solution. So, same procedure. If x equals 9 over 4, then is it true that 5 times 9 over 4 plus 1, plus 1 minus square root of 9 over 4 is equal to positive 5. Yeah, okay, I wrote everything correct. Well, let's see. Of course, recall back in middle school and even in maybe a few years ago back in high school or even the first half of Algebra 2 or whatever. When you have an integer multiplying a fraction, you specifically multiply this integer by the numerator and keep the denominator. Okay. Oops, low battery. Oh my bad, there was some low battery on my phone. Well, let's see. So underneath this square root, I'm going to have 5 times 9, which is 45, over 4 plus 1 equals keeping square root of 9 over 4 the same and bring down everything else. Well, of course, you have a fraction adding an integer. By finding the common denominator, we can tell that the common denominator is going to be positive 4. So we got 45 over 4 plus 4 over 4. And of course, keeping everything else as well, with the common denominator 4 and 4, we have the common denominator staying the same, and adding the numerators 45 plus 4, 45 plus 4, yeah, it's going to give us numerator 49. So we have square root of 49 over 4, and we still have minus square root of 9 over 4, and is that equal to 5? Well, by the laws of exponent, every time when you have a fraction underneath the radical, the laws of exponent allow you to quote-unquote distribute the exponents, okay? So recall that anything underneath the square root, my bad, is the same as that thing itself raised to the 1/2. And of course, I know that this step is optional for a lot of you because a lot of you can do mental math easily, but I would recommend to rewrite the square root into its fractional exponential power form, okay? So like this. Now, because inside the parentheses, you only had division, the laws of exponent allows you to, again, quote unquote, distribute the outside exponent to each of the one on the inside. Well, every term by itself is the same as that term itself raised to the invisible positive 1 power. Hopefully you can see it here. So by multiplying the outside exponent to each of the one on the inside, you would have 1/2 times 1, that goes with the 49. So that's going to give you 49 to the 1/2 over 1/2 multiplying the exponent 1, that is going with the 4. You would have 4 raised to the 1/2. And the same thing right here. 1/2 times 1, you got 9 to the 1/2. of course 1/2 times 1 right there, you would have 4 raised to the 1/2. Okay, and of course simplifying everything, rewrite it into square root form. Oops, I can see it here. There we go. Rewrite the fractional exponent into square root form. You got 49 raised to the 1/2 being square root of 49 over 4 raised to the 1/2 being square root of 4 minus 9 raised to the 1/2 being square root of 9, and the same thing. Okay, well, square root of 49 is 7, square root of 4 is 2, square root of 9 is 3, square root of 4 is again another 2. Is that equal to 5? Common denominators, keep it the same, just subtract the numerator. Well, 4 over 2 is 2, and that is not equal to 5. So that means we know that x equal 9 over 4 is the extraneous solution. So I'm out of room here, so I'm just going to write just a little on top right here, okay? Then x equal 9 over 4 is the extraneous solution. And that is it, you guys, for this problem. So I know that it's a little tedious, and I know that's a lot to show, but hey, when you do math, you always want to show your work, okay? And I do apologize for constantly rearranging my paper because I gotta make sure that I can write comfortably. Otherwise, my writing is gonna be messy. But hopefully this makes sense, okay? And of course, if you have any question, please leave a comment, leave a like, subscribe, and send me a message directly on YouTube or in the comment if you have any question, comment, or concern, okay? Sorry for rambling on so much, and thank you for watching, you guys.